In the Home Automation Kit, in addition to the IoT board, you'll also find a Stepper 2 click and a stepper motor. This video explains how to connect those components and writing a driver which makes the motor spin. Firstly, insert the click into the IoT board and connect the motor according to the wiring diagram currently displayed on the screen. Open Atmos Studio and create a new Atmos Star project with the AVR-IoT WG sensor node example as we did in the previous video. Select the PinMux tab. The Stepper 2 click is connected to the microcontroller through 5 pins. The port PD7 is connected to chip enable. It must be low for the device to function. The pin PA0 is connected to reset. If this pin is low, the chip is reset. The port PC3 is connected to sleep. If this pin is low, the device enters sleep mode. The port PD4 is connected to step trigger. For every pulse sent to this pin, the motor steps 1 time. We'll connect this pin to a PWM driver later in the video. The port PD6 is connected to direction. If high, the motor rotates clockwise. If low, it rotates counterclockwise. The timer module can be used to generate a PWM pulse. According to the datasheet, PD4 can output the 4th waveform generator output, which is controlled by timer A. Go to Dashboard, add software component, and select timer. Set all the settings under the timer A module to the same settings currently displayed. For more information on why this configuration was chosen, please read the Getting Started guide. Now for some code. We're going to implement motor set direction, set speed, start, stop, and reset. The first 3 functions here toggles the appropriate pin on the click, as we discussed previously. For instance, reset toggles the reset pin, and set direction toggles the direction pin. The function which requires a bit more explanation is the set speed function. The speed of the motor is controlled by the period of the PWM pulse. The higher the period, the lower the speed. The speed parameter is a percentage of a maximum and minimum period. When the speed is 100, the PWM pulse should have the lowest period. We'll use a minimum period of 1 millisecond and a maximum period of 5 milliseconds. Finding the targeted period is equivalent to finding a point on a line between 2 points, as illustrated on the currently displayed figure. This gives us the period equation in the code. The remaining lines converts this period to the equivalent HPER register value. Finally, we must connect the motor to the cloud. On the AVR-IoT webpage, we had 2 toggles, one to start-stop the motor and one to set the direction. To control the speed, we'll use a slider from 0 to 100. The data sent from the cloud to the device is in JSON format. The device must parse this string and act accordingly. For instance, when a start command is received, the motor start function is called. We also print the received message as a debug message, which can be read from a program such as MPLAB Data Visualizer or PuTTY. When we press the send button on the web page, the motor starts rotating and the command is printed in the command line. We can also adjust the speed, change direction, and stop the motor.